Hello everyone and welcome back to Quantum Science. In today's video, we are diving into IGCSE Chemistry Chapter 1, States of Matter. I've prepared a set of carefully selected past paper questions from the last 5 years, and together we will go through each one step by step. So, let's jump right in. Now let's see question 1. Which row about a change of state is correct? Option A here, he say the change of state from solid to liquid, and the energy change is heat given out. Do you think so? Just imagine the solid here like ice cube. Then the liquid here is liquid water. So if you want to turn from ice to liquid, that means you have to heat it, right? You have to increase the temperature. So that means heat is taken in here. It's not out. And the process from solid to liquid is called melting. That's correct. But since the energy change part is wrong, so that's not the answer. And the change of state from gas to liquid, and we want to cool it down, right? From water vapor to liquid water. So that means heat is taken out because we want to decrease the temperature or cool it down. And the process is called, it's not evaporation, but it's called condensation. Option C here, he said from solid to gas and heat is taken in. Yeah, that's correct. And the process is called sublimation. That's correct. So the answer here is C. What about option D? From liquid to solid. Okay, so imagine just like liquid water turned to ice cube. And the energy change is heat is given out. Yes, that's correct, because we want to cool it down, right? That's why we have to decrease the temperature, so heat is given out. And the process here is called, not called condensing, but it's called freezing. So this part is wrong. So that's why the correct answer is C. Question 2. Brownian motion and the diffusion of gases provide evidence for the particulate nature of matter. Which row identifies an example of Brownian motion and how molecular mass determines the rate of diffusion of gas molecules? So please remember that Brownian motion is the random movement of particles in a liquid or gas produced by a large number of collisions with smaller and invisible particles, right? So the Brownian motion is going to be the random movement. So it's going to be between A or B, right? While diffusion here, as we know, heavier gas molecules will diffuse more slowly, while the lighter gas, it means have the smallest molecular mass, it will diffuse more quickly. So this and this. So the correct answer here is B. Question 3. Which gas has the fastest rate of diffusion? To find the fastest rate of diffusion, we have to know the molecular mass, because we have to know which one is the lightest molecules, right? So in this case, we have to see the periodic table. So from the reference of the periodic table here, we know if the atomic number is at the up part, right, at here, while the relative atomic mass is at the down part. Okay, now let's see for everything. So carbon here. So carbon, the mass is 12. Oxygen, the mass is 16, while sulfur is 32. Please note that number. Now let's find the molecular mass for each of them. For option A, hydrogen, H2. So how to find the molecular mass? So a single hydrogen, the mass is 1. So we have 2 hydrogen here, H2. So it's going to be 2 times 1, which is 2. While carbon is 12, and we have 4 hydrogen, a single hydrogen is 1. So it's going to be 4 times 1. And this one equals to 12 plus 4, which is 16. In here is 12 plus how many oxygen we have here? 2 oxygen. And 1 oxygen is 16. So it's going to be 12 plus 32, which is 44. And here sulfur is 32. And how many oxygen we have? We have 2 oxygen. So that's why we have the times with 16, because 1 oxygen, the mass is 16. So it's going to be 32 plus 32, which is 64. So this is all the value for their masses. Now, who is the smallest mass? The smallest mass is H2, which means H2, hydrogen, is going to be the fastest rate of diffusion because it is the lightest, the smallest value of molecular mass. So the answer is A. Question 4. Which two gases will diffuse at the same rate at the same temperature? If we are talking about the same rate, it means they will have the same molecular mass. Right? So that's why we have to find the formula for each of them. So carbon monoxide, the formula is CO, while carbon dioxide is CO2. Carbon monoxide is CO, nitrogen. So remember, nitrogen and oxygen, all halogen or group 7, they exist as diatomic gas. So that's why you have to put 2 in here. Okay, it's not a single N, but it will be N2. Now chlorine is also group 7, which is halogen. So that's why we also write it as, there is an index 2 in here. Yeah, sorry. In that for chlorine, the symbol is Cl2 and fluorine is F2. And nitrogen here is N2, oxygen is O2. Now let's find the mass from periodic table. So as we know, the mass for carbon is 12, nitrogen is 14, oxygen is 16, fluorine is 19, and chlorine is 35.5. Now let's go back to the question. Now let's find for carbon monoxide, it's going to be 12 plus 16, which is 28. While carbon dioxide here is going to be 12 plus 2 times 16. So equals to 44. And here it's going to be 28. We already find the value from option A. And here it's going to be 14 times 2, which is 28. So this is going to be the answer. But let's continue with option C. Cl2 is going to be 35.5 times 2, which is 71. And this is going to be 19 times 2 equals to 38. Okay. And N2, we already find it in option B, which is 28. And O2 is going to be 16 times 2, which is 32. You can see very clearly if the answer is B, which is the same rate, because they have the same molecular mass. So the answer is B. Alright, make sure that you pause every question and answer it by your own to see how far is your understanding for this chapter. Now, question 5. Which gas diffuses the most slowly? So slowly here is going to be the heaviest gas, right? Or we can say the greatest mass, isn't it? So from the periodic table, you will know if the atomic relative mass of carbon is 12 and hydrogen is 1. And we have 4 hydrogen here, so it's going to be 4 times 1. So it's going to be 16. Carbon is 12, oxygen is 16, and we have 2 oxygen here, so it's going to be 16 times 2. So it's going to be 12 plus 32, so it's going to be 44. And hydrogen is 1 times 2 here because it's H2, so equals to 2. While here nitrogen is 14. And hydrogen is 1 times 3 because we have 3 hydrogen, so it's going to be 17. So who is the greatest mass in here? That's going to be 44, which is carbon dioxide. So the correct answer is B. Now question 6. Substance M is a solid at 30 degrees Celsius. The substance is heated to 80 degrees Celsius and its temperature measured as it cools down to room temperature. The cooling curve is shown. And a question asking about between which time is the substance M freezing. So it says that it's a solid at 30 degrees Celsius. So here is 30. So it's gonna be at this place. So this place is already in a solid state. So where is the freezing point? So the freezing point is gonna be in here. Okay, so anything below freezing point is gonna be solid. So the question said between which times is the substance M freezing is gonna be between these already start to freezing, right? So the answer is B, Q and R. Now question 7. The diagram shows the result of dropping a purple crystal into water. So this is the purple crystal. So the question asking about which processes take place in this experiment. Okay, so here there's the chemical reaction, diffusing and dissolving. So first of all, remember that diffusion is not a chemical reaction because in diffusion, the particles just move from area of high concentration to an area of low concentration, spreading out until evenly distributed. So what happens in a chemical reaction is the bondings are broken down and there are new bonds that are formed, creating new substances with different chemical properties, right? So there is no chemical reaction. So I'm gonna lock my answer between C or D now. And at the end, after 5 hours, it will turn into a purple solution. It means you want to make sure if this purple crystal can dissolve, right? It can dissolve in the water and it will turn into a purple, into a solution. So solution here is mean you mix something. For example, you are using water or alcohol or something liquid, and this purple crystal will dissolve, and after that it will distribute it to every single area in this beaker. So it will diffuse, right? So diffusion happened and dissolving also happened. So that's why the answer is D. Question 8. 4 physical changes of ethanol are listed: condensation, evaporation, freezing, boiling. In which changes do the particles move further apart? To answer this question, we have to know each of these terms. So condensation is the physical changes from what? It is from gas to liquid, right? While evaporation, its mean is from liquid to gas. While freezing, it's from liquid to solid. And boiling is from liquid to gas. The difference between boiling and evaporation: boiling is the physical process where a liquid changes into a gas throughout the entire liquid, not just at the surface like evaporation. It means evaporation only happens at the surface of the liquid, right? So what will happen if the gas turns into liquid? It means we have to decrease the temperature, right? We have to cool it down. So the particles are getting closer together. While the question here is asking about the particle will move further apart. So it means we have to increase the temperature. So the particles will gain kinetic energy, right? And it can only happen, in this case, it's liquid and gas, right? Because the process of freezing, which is from liquid to solid, we have to decrease the temperature. So the particles will lose kinetic energy and getting closer together, right? So the correct answer is 2 and 4. So that means it's C. Question 9. Nitrogen is heated in a balloon which expands slightly. So which statement about the molecules of nitrogen are correct? Okay, so the key here is heated. So that means the temperature of nitrogen is increasing, right? So what will happen if you increase the temperature of a solid, liquid, or gas? So the particles will move further apart and faster, isn't it? So these and these is the correct answer. The particles will vibrate even more, it will expand, move further away, and faster. While the statement number 3, it says that they remain the same distance. Nope. So it will move further apart. And their speed remains unchanged. So this one is also wrong because it will move quickly, it will move faster, it not remain unchanged here. So the correct answer is 1 and 2, which is A. Question 10. A gas is placed in a sealed container. The gas has a pressure of 1 atmosphere and a temperature of 50 degrees Celsius. It is heated to 100 degrees Celsius. Which row describes the cause of the pressure of the gas and the effect of increasing the temperature? So you can see here the effect of increasing the temperature. So it starts from 50 to 100 degrees Celsius. So please remember that the pressure of a gas comes from its particles colliding with the walls of the container. An increase in temperature will also increase the kinetic energy of each particle, so the gas particles move faster, impacting the container's wall more frequently. The pressure that a gas creates inside a closed container is produced by the gaseous particles heating the inside walls of the container. The cause of gas pressure here is going to be the collisions between gas particles with the container, right? So I'm going to lock my answer between C or D. While how the effect of increase the temperature of the gas? So of course the collision will become more frequently, right? So that means the average speed of the gas will also increases because you increase the kinetic energy. So here it should be more. So that's why this is wrong and this is the correct one. So that's why the correct answer is D. Question 11. Solid X is heated for 600 seconds. The graph shows the heating curve that is obtained. What is the melting point of X? So remember, in heating curve, the horizontal or flat line here is the melting point. And the above flat or horizontal line, it is called the boiling point. So above the boiling point, the state is always a gas. Between melting point and boiling point is liquid, while below melting point is a solid. So the question asking about what is the melting point of the gas, so it is in here. So in the middle is going to be 150, so 160, 170. So the answer is B. Question 12. A gas is heated. The pressure is kept constant. Which statement describes the behavior of the particles in the gas? So remember, a gas is heated, so that means you increase the temperature. So what will happen if you increase the temperature? Yeah, so it will gain kinetic energy, it will move faster and further apart, right? So the answer is B. Question 13. Sodium chloride is a liquid at 900 degrees Celsius. Which row describes the arrangement and the motion of the particles in sodium chloride at 900 degrees Celsius? Okay, so the arrangement of particles here, we have regular and random. Remember, the arrangement of particles, if it's regular, then it is a solid state, while random here, it can be liquid or gas. And the motion of particles vibrate about a fixed point. So this is only happen in a solid state, while move randomly, it can only happen in liquid or gas state. So the question is a liquid. Question asking in a liquid state, so that's going to be random. The arrangement of particles is random and the motion of particles is also move randomly. So the correct answer is D. Question 14. Hydrogen chloride gas HCl reacts with ammonia gas NH3 to form solid ammonium chloride. The apparatus is set up as shown. After a few minutes, a white cloud of solid ammonium chloride forms where the two gases meet. So after they form, they meet in here, which is solid ammonium chloride. The experiment is repeated by using hydrogen bromide gas HBr in place of hydrogen chloride. How far along the tube does the white cloud of solid ammonium bromide form? So in this case, to know which gas travel faster or slower, we have to know the mass, right? So we have to know the mass of hydrogen chloride here, HCl. So if you check in the periodic table, the mass of Cl is 35.5. Hydrogen is 1. So the mass of HCl is 1 plus 35.5 equals 36.5. While HBr, if you check in the periodic table, the mass of Br is 80. So HBr, hydrogen, is 1 plus Br is 80, so it's going to be 81. So which gas have greater mass? So it's going to be HBr, right? So because the greater mass, as we know, based on the theory, greater mass will travel slower. So if by using HCl, it will travel at the position of B, which is in here. So that's why if you're using HBr, because it has the greater mass, so it will travel slower. So it is going to be at the left side, more into the left side. So that's why the correct answer is A. Question 15. A cooling curve for a substance is shown. Which statement is correct? So since this is a cooling curve, so that means we read this curve from up to down, like this. So in cooling curve, this is what we call condensation point. While in heating curve, this is called boiling point. While the position at X, Y here, this is what we call freezing point. While in heating curve, this is what we call melting point, right? And here, the state is just the same like heating curve, which is gas. Between condensation point with freezing point, this is going to be liquid in here. And Y to Z is going to be solid. So the question asking which statement is correct between U and V, the substance is condensing. U and V, it's not condensing, it's just a state, which is gas. So this statement is wrong. Between V and W, heating is being absorbed from the surrounding because we want to cool it down, right? Because it is a cooling curve. So gas want to turn into a liquid in this case. It's not being absorbed because we want to cool it down, so we want to decrease the temperatures, and that's why heat is being released in this case. What about C? Between W and X, the particles are close together and randomly arranged. Yes, that is because between W and S is a liquid, and how is the arrangement of a liquid? Very close each other, right? But they still can slide over each other. Yeah, still close, but not as close like in the solid state. What about D? Between Y and Z, the substance is changing from liquid to a solid. Is that true? Y and Z, the substance is changing from liquid to solid? Nope, it is just in a solid state. So it's not changing, it's just a solid state. It's not changing from liquid to solid. So the correct answer is C. Question 16. A gas is placed in a sealed container with a fixed volume. The gas is heated. So what will happen if you increase the temperature of a gas? That means you heat it, right? So you are increasing the temperature. So as the effect, the gas will expand, right? The particles of the gas will expand. It will move faster and quickly in all directions. And the pressure of the gas will also increase. It means if you increase the temperature, you will also increase the pressure of a gas. So for statement 1, the gas molecules move around faster. Yeah, that's correct. Statement 2, the gas particles collide with the walls of the container more frequently. Yes, of course, because the gas move faster. That's why the chance of the particles to collide each other is also increases. What about 3? The pressure in the container decreases. Not decreases. This should be increases, right? So the correct statement is 1 and 2. So the correct answer is A. Question 17. A sample of ethanol is heated at a constant rate. The heating curve for this sample is shown. Which statement about the heating curve is correct? Now let's take a look at this graph. So in heating curve, the upper horizontal line here, this is what we call boiling point, right? While the lower horizontal line, this is what we call melting point. And above boiling point is always gas. Between melting point and boiling point, this is a liquid. While below melting point, it's a solid. Now let's check for each option. Ethanol changes its physical state between 3 and 4. It's not changes its physical state because it's just liquid, right? Between 3 and 4 is a liquid, so this option is wrong. Ethanol condenses between 2 and 3. So between 2 and 3, so that means it wants to change from solid to liquid, right? From solid to liquid, this is what we call melting. So it's not condensing. So it's wrong. Option C, energy is absorbed between 3 and 4, but not absorbed between 4 and 5. So in heating curve, the temperature is always increases. So that means energy is absorbed in all of the stage, right? Between 1 and 2, 3, 4, and 5 and 6. So this option is also wrong. Now more energy is absorbed between 4 and 5, so in the boiling point, than between 2 and 3, so in the melting point. Is that correct? Yes, in boiling point, that means the temperature is higher than the melting point, right? So the energy in boiling point is more than the state in melting point, which is at 2 and 3, right? So the correct answer is D. Question 18. An ice cube melts. What happens to the molecules of water in the ice cube? Okay, now let's take a look. Ice cube, that means the state is solid, while pool of water here, the state is liquid. So what will happen when solid turn to liquid? It's not evaporate. Evaporate, it means from liquid to gas, right? So from solid to liquid, this is what we call melting. So this is wrong. They dissolve. Okay, so they are not dissolving because it's just like the changes of state from solid to liquid, which is melting. So do you think they gain energy? Yes, it is. Because to change solid to liquid, we have to increase the temperature. Increasing the temperature is mean we give energy, right? We give the heat because heat is a kind of energy. So that's correct. And they are not losing energy. If they lose energy, it means we want to cool it down. We want to turn the gas into liquid or from liquid to solid. So this is wrong. So the correct answer is C. Question 19. A sample of a liquid X is heated to a temperature above its boiling point. X is then cooled so that it condenses and then freezes. Which graph describes the change in temperature of X over time? Okay, so we know it starts from a liquid and it's heated above its boiling point. Above its boiling point, there's gonna be a gas. So first of all, let's draw the graph of heating curve. Let's say like this. Okay, so it's gonna be here. Okay, as we know, here's gonna be the boiling point, right? And here's gonna be the melting point. While the reverse of heating curve, this is what we call the cooling curve. So in here, this above boiling point is gonna be gas. Gas here, and here's gonna be liquid, and here's gonna be solid. Liquid and solid. While in cooling curve, this is what we call condensation point. While in here, this is what we call freezing point. Okay? Now, let's see the statement again. X is then cooled. So after it's reached, the liquid X is heated to temperature above its boiling point. So it's going to be the gas. And then it is cooling down from gas into a liquid. So of course, it will reach its condensation point. Remember, boiling point is just the same with condensation point. So the line here should be the same with this line. Okay, and then the liquid is gonna be in here. Then the melting point is just the same height with the freezing point. And then it will turn to solid because it's a then freeze. So which graph describes the change in temperature of X over time? So which is the same with the graph at D. So the correct answer is D. Question 20. Which two changes when applied at the same time to a fixed amount of gas cause the greatest increase in volume of the gas? Okay, so first of all, we have to know the concept about the increasing of volume towards the pressure. Imagine if I have a container and it contains of 1, 2, 3, 4, 5 particles. And now I'm increasing the size, or I increase the volume of the container. So the number of particles is still the same, 1, 2, 3, 4, 5. So what do you think about the pressure in here? If I increase the volume or the size of the container, of course, the pressure will be low. Why? Because the distance between particles are very far apart. Now compare if I make it smaller. The number of particles still 5. 1, 2, 3, 4, 5. So what do you think about the pressure here? The pressure here, of course, gonna be higher than before. Why? Because the particles are getting closer to each other. So that's why in here, the pressure is very high, right? So what causes the greatest increase? So it means if you increase the volume of the gas, you will decrease the pressure, right? And he say the greatest. So I will choose decrease the pressure, and the greatest gonna be decreased by 20%. And what about the change in temperature? If I want to increase the volume of the gas, so that's why I have to increase the temperature. Why? Because increasing in temperature will cause the particles to gain kinetic energy. It will move faster and further apart, right? So that's why I will increase the temperature, and here I can only choose increase by 10%. So that's why the correct answer is C. Now let's discuss about the structure question. Here are some examples of structure question. Question 1. The melting point and boiling points of fluorine and sodium fluoride are shown. Deduce the physical state of fluorine at negative 195 degrees Celsius. Use the data in the table to explain your answer. Okay, now let's take a look at fluorine. And the melting point is negative 220 and the boiling point is negative 188. As we know, the heating curve, the graph is going to be like this. So boiling point is always above the melting point, right? And above boiling point is the state is gas. Between boiling point and melting point is the liquid. While below melting point is gas. So fluorine, the melting point is negative 220 degrees Celsius, while the boiling point is negative 188 degrees Celsius. So where's the position of negative 195? So it's gonna be here, right? So here it's gonna be negative 195 degrees Celsius. So that means the state is liquid. You can say here the physical state is liquid. The explanation is because negative 195 degrees Celsius is between melting point and boiling point. Question 2. This question is about states of matter. Complete the table, use ticks and crosses to describe the properties of gases, liquids, and solids. Okay, so the first thing is the particles are touching. Do you think gas is touching each other? No, right? So we don't Take this one, we are crossing. While the liquid, they are still close to each other, but they still can move or slide over each other. While the solid is in a regular straight pattern, right? They are very close and can only vibrate in its position. So that's why this is thick. What about the particles have random movement? Yes, gas, because the distance between particles is very far apart. So that's why gas can move randomly and quickly in all directions. What about liquid? The particles have a random movement? Yes, because they still can slide over each other. But in solid, they are in a straight, regular, and tidy pattern and can only vibrate in fixed position. So they cannot have the random movement. What about the particles are irregularly arranged? In here, gas and liquid, they are randomly arranged, right? So here is going to be cross, cross, and solid are regularly arranged. Next question. Substances can change state. Boiling and evaporation are two ways in which a liquid changes into gas. Describe two differences between boiling and evaporation. Okay, so what do you know about boiling? So boiling happens at a fixed temperature, while evaporation can happen at any temperature, right? And the other one is boiling can occur throughout the entire liquid, which you can see the bubbles form inside that liquid, while evaporation occurs only at the surface of the liquid. So in here, you can write boiling happens at a fixed temperature and boiling occurs throughout the liquid, or you can say the bubbles form inside that liquid, right? Now, name the change of state when a gas becomes a liquid. A gas becomes a liquid, this is what we call condensation. While a solid becomes gas, this is what we call sublimation. Alright, next question. A substance boils at temperature X and melts at temperature Y. Complete the graph to show the change in temperature over time as the substance cools from temperature A to B. Okay, so it's from A to B. So he said it cooling down, right? So it's gonna be go to Y, right? So the Y is in here and it's gonna be here and then go to part B, which is here. So if you want to see the explanation, so this is what we call boiling point, while in here the flat one is the melting point. Again, boiling point is always above melting point, right? So the state above boiling point, this is what we call gas. Between boiling point and melting point, this is what we call liquid. And below melting point, the state is gas, right? Okay, but we don't have to write it all the explanation because the question is only asking about the complete the graph to show the change in temperature. So I think this one is enough. Just like that. Okay, so this is the answer. Now question 3. The table shows the melting point, boiling points, and electrical conductivities of 6 substances D, E, F, G, H, I. And identify the substance which is a liquid at 25 and a gas at 25 degrees Celsius. Okay, so we have to draw the heating curve or the graph. And let's see for substance D in here. So this is substance D. The boiling point is always above the melting point, right? So 2, 5, 6, 7, and this one is 1, 0, 8, 3. So where is 25? 25 is below 1083. So this is going to be 25 here. So again, the state or the physical state below melting point is solid, right? So in here, this is going to be solid. Okay? Now let's take a look for substance E. So E here is 79, the boiling point, and the melting point is negative 117. So where is 25? So here is going to be 0 and 25 is going to be in here. So it's between melting point and boiling point. So that's why this at 25 degrees Celsius, the state is liquid. Now let's see for substance F. F, the boiling point is 4,827 and the melting point is 3550. So where is 25? 25, of course, is going to be very far down here. It's 25, right? It's still below melting point, so that's why the state here is going to be solid. Now let's take substance G. So the boiling point is 445 and the melting point is 119. So where is 25? Still in here, right? So it's below 119, which is below melting point. So that's why the substance is also solid in here. The physical state is also solid. Now let's take for substance H. The boiling point is negative 196 and here the melting point is negative 210. So where is 25? 25, of course, is going to be above here. Very far away, right? Above boiling point. So the substance here is going to be gas. Right? For substance I, the boiling point here is 1413 and here is going to be 801. So where is 25? 25 is going to be below 801, which is below melting point. So that's why the state is going to be solid. So the question asking a liquid at 25, so the answer is E, while a gas at 25 is H. Question 5. Element X can undergo the following physical changes. Name each of the numbered physical changes shown in figure 1.1. Okay, so for number 1, you can see the arrow is from solid to liquid. So from solid to liquid is called melting. Number 2, the arrow is going down, so that means it's from gas to liquid. From gas to liquid is called condensation, or you can say condensing. Okay, condensation is also approved. Next, number 3 is from liquid to solid. From liquid to solid, it is what we call freezing. Number 4 is from liquid to gas. From liquid to gas is called boiling or evaporation, right? You can say boiling or evaporation. Next, one difference between boiling and evaporation is the rate at which processes occur. State one difference between boiling and evaporation. So please remember, boiling happens throughout the liquid at a fixed temperature, which is at the boiling point, while evaporation only occurs at the surface of the liquid and can happen at any temperature below the boiling point. So you can choose any of them that I say previously. Okay, so you can choose one of them. For example, you say boiling happens throughout the liquid, while evaporation only occurs at the surface of the liquid. And you can get 1 mark because this is only 1 mark. Or you can say boiling happens at a fixed temperature, while evaporation can happen at any temperature. Okay, you choose one of them. So I give you 2 choices in here. You just choose one of them and that's the correct answer. Next, describe the separation, arrangement, and motion of particles of element X in the solid state. So how is the separation? That means the distance between particles in a solid state. How? They are very close each other, right? You can say close each other. While the arrangement is in a straight and regular arrangement. Okay, straight or regular arrangement. Then how is the motion? The motion, it can only vibrate, right? So you can say vibrate in fixed position. So yeah, that's all about some past paper questions in this question and answer section. Thanks for watching. Don't forget to like, comment, and subscribe. See you again.